Hi there, so today we're looking at critical values, which is still within hypothesis testing, but it's just looking at particularly identifying the region within which we would be rejecting a null hypothesis. So if you've got any values coming within here, that's the most likely result according to the probability that you think you're working with. But if you get anything within this, I mean this looks like a sort of 10% surety that we're going for, then at that point we'd be thinking, oh, there's maybe enough evidence to reject our null hypothesis and we need to think again. Right then, so here's our first example. It's quite a boring one, but have a go at it if you can. If you'd like a bit more context, you could imagine that Mr. Cooper and Mr. Godber play golf together quite a lot, and it turns out that Mr. Cooper seems to be a bit better than Mr. Godber. And he says that the chance of Mr. Godber beating him is only 0.35, and that's his null hypothesis. Mr. Godber says, I don't think so actually. I need an alternative hypothesis, that is, I'm better than that. So that is the 0.35. Now it says a single observation is taken. That single observation is 6 trials. So we're going to go out and we're going to play 6 games of golf. Now what's the bell curve going to look like for that? Well, the chances are that Mr. Godber will win less games than Mr. Cooper. So if we're looking at how many games Mr. Godber's going to win, the most likely number of games he's going to win is going to be less than 3. You've got 0 there, you've got 6 there. And what we're interested in is finding out how many Mr. Godber would have to win before, which would have a likelihood of happening at less than 5% for us to be able to go on with that. So what we're looking at, that doesn't make all that much sense maybe. So let's get the calculator and let's just crunch it through and then we'll put it on the thing. So we need to go to master, no we don't, we need to go to statistics. We need to go to distribution, binomial, and BCD, the cumulative distribution. Right, and so what if we were saying, what would be the chance if Mr. Godber played a blinder and won all 6? That would certainly seem to say that Mr. Cooper's not right. So we're going for, it's got to be 6 out of 6. And the chance of winning supposedly is 0.35. What is the chance of that happening? The probability that Mr. Godber wins 6 is only 0.00183. So that's not very likely. That is just almost 0.2% chance of happening. It's not very likely to happen. A bit depressing actually. So that is all 6. So that's definitely going to be in the critical region. The critical region is going to be up here somewhere, and the amount that will just take in 5%. How about if won 5 or more? So let's go back and do that. We go into the lower amount being 5, upper being 6, and this is making it 0.02232. Now that is 2%, isn't it? 2.2%. So that, if Mr. Cooper were to lose 5 games, that would mean that we've got enough to reject his null hypothesis. Let's go back again and see what it would be for 4. And the way that's changed, it looks like it might be enough to say, it's okay, right, now that has got a nearly 12% chance of happening, because Mr. Cooper's not that much better than Mr. Godber, that Mr. Godber could win 4 games in a row. So even though Mr. Godber would think, yeah, that shows I'm better than you really, actually it doesn't, because the probabilities are there. Whilst it's not the most likely thing to happen, it's definitely well possible. So the critical region for the test, the critical value that we're looking at, is actually going to be 5. However, this region is not 5%, but 2.2%. And that was actually going to be the second question on here. So, stating the actual significance level of the test would just be to say, well, the actual significance level of the test is this bit here, isn't it? It's 2.23%. Okay. Oh, I haven't actually said the critical region is 5 or 6. Or you could say more than 4. Either would be absolutely fine. Right, pause the video and give this one a go. So the big difference here is that the alternative hypothesis does not say more than or less than, it says not. And that means we're dealing with two possible ways of the thing not being true, the probability not being right. It could be, so it's saying the probability is 0.25, which means the chances are edging towards things not happening rather than happening. So we're probably looking at something a bit like that. But we're looking at two different ends. Now it says, using a 2% level of significance, the probability in each tail should be as close as possible to 1. So you're basically saying you've got two 1% significant tails. So you've got 1% up here, the top 1%, and you've got the bottom 1% down there. And so in order to find that, we need to have a little search on the calculator. So if it's only 1% that we're looking for, we'd probably start with something quite small. So if we were to say at the bottom end, maybe what's the chance that there's only, I'm going to go for, at the bottom will have to be 0 up to maybe 3 out of 40, and the probability is 0.25. Have a look at that, and that was x is less than or equal to 3 is equal to 0.00469. Now that's not too bad a start actually, because we want 0.01, so it's not far away. So I'm just going to up that by 1 to 4 and see what I get, and I get 0.016. So actually that is more than 0.01, and that is less than 0.01. And it's quite misleading the way it says the probability in each tail should be as close as possible to 0.01. It can't exceed it though. So actually 0.016, is that a little bit closer? Maybe not closer than that. It's actually slightly further away, isn't it? But you want it, it's got to be less than 1%. So one of our regions is going to be x is smaller than or equal to 3, and the other tail, the top end tail, is going to be how many can we afford to have off the top. Now as we're expecting it to be more down there, I'm thinking that we can probably go a bit low, bit more than that. So let's go for 30 and see what that gives us. So we're going to go lower being 30, upper being 40. Oh, that's really unlikely, really unlikely. 4.6 times 10 to the negative 11, that's way below 0.01, so we're going to need to make that a load more likely by allowing more results in. So if we go back to here and we go for 25, that's still, I'm not even going to bother typing that in. So I'm then going to go back up here, see what's 20 like. that's still way too less. So let's go for, oh, I don't know, let's go for 15. And that is a little bit too much, isn't it? So let's say 15 is 0.0544. So we don't want that much. We're going to need to nudge that up a bit. So let's try 16. And that's come down quite nicely, 0.26, but that's still more than 0.01, more than 0.01. So let's go for 17, and hopefully that should be enough now. And it's 0.01156, which is a tiny bit more, but it may be closer. It may be closer than the 18, so let's give that a go. Sorry, I think I said that the other way around. Because they've told us it should be as close as possible, that is what it needs to be, as close as possible. That's 0.00465, which is nearly 3.5 away, whereas that is only 108, so that is going to be closer. So that's more than 0.01, that's less than, but that one is closer. So our other one is going to be more than that. So we've got x being 0 up to 3 and the number of them being more than or equal to 17 but less than or equal to 40, because we've only got 40 tests. And then part B, the actual significance of the test, we're going to need to add together the two things we've got. So I've got my 0.004696 was my first one, and I've got my 0.01156. If I add those together, I get 0.01625. So what's that? That is 1.6, round that to 3 for 3 significant figures, percent. Okay, I've got a couple more for you to have a little go at. I won't do as much talking through these, just give them a go and see how it goes from there. So the first thing to do here is make a little sketch, and 0.4 is just before halfway, so it's going to be about there. And it's saying 5% level of significance, but it's a not that, so we need 2.5% there, and we want 2.5% there. So aim for that to see if you can find your critical values. And so the real critical ones you needed to find was the ones either side of 2.5%, which were 4 and 3 in the lower tail, and 12 and 13 in the upper tail. The two satisfying it were 3 and 13. So the critical region is going to be x being greater than or equal to 0 and less than 3, and also between 13 and 20, as that's the most tests we've got. And the actual significance level of the test is going to be what you get when you add your 1.596% plus your 2.103%, which should have given you 3.7% once you've rounded that one. Okay. Okay, here's your last question, giving you a little bit of context here, and we've got looks like an Italian restaurant. So give this a go. So your suitable model and your suitable null and alternative hypothesis, well, it should be a binomial, and then you just need to write down something looking like this. Okay, so you don't have to write down binomial as long as you've got your b with your brackets in there, and we've got an n in there because it hasn't said how many customers at this point, so you don't need to make some up, you just need to put down that it will be some customers. And in the basic model you'll have a p for probability, but that probability will be 0.2 as that's a fifth, and then she's just saying that she thinks it will change. She's not saying whether it's going to make people like it more or less because she doesn't know yet. Okay, now we're going to have a random sample of 25 customers, so give the rest of it a go. So hopefully you got something like this. You probably put in more values before you got to the right ones, but 0 wasn't enough, but 1 was a little bit too much, but definitely the closest to 25 to 2.5%. And again with the 9 and the 10, 9 was too much, but 10 or more was too little, but clearly closer to 2.5 than that was. So that means that your regions should then look like being between 0 and 1, and being between 10 and 25. Now if you wanted to, you could put a not or equals to at that point there and put a 9 instead, couldn't you? Or you could just put x is less than 2 instead of or equal to 1. Anyway, the probability of incorrectly rejecting it would be these two probabilities added together. So if you add 2.739% and 1.733%, then I think you should be right in saying that that should give you 4.47%. And that's it for today. We're going to look at more detail next time at single-tailed tests.